Okay, let me give you guys a Calculus 2 problem. So let's say you're trying to design some sort of reservoir here, where the shape of the reservoir must be in the form of y equals x squared. Find the height of your reservoir in such a way that the volume is precisely 10. So for example, this shape here has to be in the form of y equals x squared. So you're really rotating this. So you're going to get a volume. Rotate it, rotate it, rotate it, rotate it, rotate it in such a way that the volume is precisely 10. Okay, so press pause and think about it. Press pause and have a go. Okay, so to do this, you've got to use solid of revolution. So at the moment the graph looks like this. I'm going to just switch these two around so that my graph will look like this. So it's easy for me to use, I want to integrate it so that it's of the form v equals something dx as opposed to integral something dy. So I'm going to use this technique here. Hang on. Just switch these two around. Switch these two around, and this graph will become this. So if you punch this into a graph plotter, it should draw you this weird graph. And if you feel uncomfortable with this, then rearrange it to make y the subject. So square root both sides. So y equals square root of x. When you square root something, you get the positive version and the negative version. Well, the positive square root will look like this, and the negative square root will look like this. My point is that it's perfectly legitimate just to switch them around. Now your graph looks like this. We don't really care about the negative square root, so just consider y equals square root of x. And then now you're going to use this technique called solid of revolution, where no matter where you are, let's say you're at x, you want to know the radius. So the volume is given by you integrating from 0 to h, and it's going to be something dx because you're moving in the x direction as opposed to dy. So you're moving in the x direction. Now each step of the way, let's say you're currently here. Let's say you're currently here at x. Well, you need to know the radius. Well, what is the radius? Well, you would put this, hang on, earlier we had y equals square root of x. You would put this into here, so the y would be square root of x. This height here would be square root of x. So it would be v equals this radius here, which will be square root of x. Once you've got the radius, quickly pi r square it. So that will give you the area of the disk. Pi r squared, and then you're summing up all the disks. So the volume is given by this. So you're moving along here. Each step of the way, you will need to know the radius, which happens to be square root of x, and then quickly pi r square it. That will give you the area of the disk. Pi r squared. That will give you the area of the disk, and then sum up all the disks. So you're taking the integral of all the disks in the x direction. Well, the volume is given by the integral from 0 to h. From 0 to h. Our job is to work out an h. That will give us a volume of 10. Later on, we're going to put 10 into the v. Well, anyway, v is given by this. So now this is a constant. It has nothing to do with x. X is our variable. So we can drag the pi out. That will then become this. And then when you square a square root, the whole thing would just be x. So it's just a matter of integrating x. So when you integrate x, it would be x squared over 2 from 0 to h. And then you would put the h into here. That will then give you this. take away, and then put the 0 into here. That will then give you this. So the volume is given by this. So now you want to find a value of h that will give you a volume of 10. So you put 10 into the V, that will then give you this, and then work backwards to find h. So h is given by this. So if you get a graph plot, y equals x squared, it will look like this red line here, and y equals square root 20 over pi. That will give you the height of your reservoir. So if you look at this volume here, this volume here would be precisely 10. Okay.